Hey everybody, really sorry we had a slight technical issue with the last session, but we've moved things around a little bit. So this is going to be a presentation, actually going to be a video presentation from Leice Lidar based in China. It's going to be innovation on remote sensing, an introduction to Leice Lidar. They're a really good company. So I'm just going to play a video. If you bear me 1 second, I'm just going to share my screen with the video, and hopefully you can see it. And we'll talk at the end. Bear me 1 moment. Okay, here it is. Enjoy.
Hello, everyone. It's my pleasure to attend this Specialist Summit on Remote Sensing Technology for Hydromet Service. I'm Songhua Wu from Leice Lidar company and also from Ocean University of China in Qingdao. I'd like to introduce our LiDAR development and applications on meteorological environment and aviation safety service. All right, so first I'd like to show where we are. So Ocean University of China is located in Qingdao. It's a coastal city in eastern China, just between Beijing and Shanghai, facing to the Yellow Sea. And we have two major campuses, first in the coastal area, another one in the Laoshan mountain area. The middle picture shows here where we are. The LiDAR lab, this building is here, and the window is the office I'm just giving this talk. The Leice Lidar company was founded by the professors of Ocean University of China since 2018. But we have, it's quite young, but we have developed the LiDAR since the 1990s. For our remote sensing team, we have 3 divisions on marine technology department. First one is satellite remote sensing for sea surface wind, temperature, and wave dynamic measurement using satellite sensors. The second one is LiDAR and ocean optics. We develop all kinds of wind, temperature, humidity, cloud, aerosol, and ocean optics LiDARs applications. The third one is marine GIS system. So for a LiDAR lab, we have 41 faculties in our department. We have 8 faculties in LiDAR lab and around 50 master and PhD students. For Leice Lidar company, we have around 50 employees. Most are researchers and engineering. In 1990s, we developed the first direct detection Doppler wind LiDAR using atomic spectroscopy filter for wind measurement. At that time, European scientists pioneered technology using fabric hole and phasal interferometer for the wind measurement as well. Later, ESA has launched the first baseball LiDAR called Aerosol satellite in 2018. I will introduce later. So this slide shows the Doppler wind LiDAR we have developed. So this in the left side, you can see the first generation LiDAR in the container. And also we developed this mobile technology for the Olympic Games sea surface wind measurement, and including other airborne and also the shipborne Doppler wind LiDAR, using the same technology that we call direct detection technology for troposphere wind measurements. Now we use this technology for the higher altitude measurement up to, let's say, 10 kilometers for wind profile every 10 to 15 meters, and use this technology to predict the trajectory of the Shenzhou spacecraft re-entry capsule. You can see the trajectory predicted by the wind profile. Around 2012, we start the development for this very compact, coherent Doppler wind LiDAR, especially for the boundary layer dynamics and wind measurement. You can see it's ground-based system. We test this LiDAR in the Tibet Plateau, high altitude application, also the very compact system in the AUV with only 20 kilogram. And we deploy this LiDAR on the Buoy to measure the offshore wind industry. Nowadays, the 3-dimensional wind scanner has been deployed to the complex terrain for the coming Winter Olympic Games in 2022. So this slide shows this Doppler LiDAR families. We have different kind of wind profiler for boundary layer measurement up to the troposphere measurement. Also the three-dimensional wind for the terrain and turbulence measurement, and also it's a very compact system for this wind turbines applications and other direct detection Doppler wind LiDAR and the water vapor and the Raman technology for aerosol profiling. Okay, this application for our Doppler wind LiDAR, including for the wind industry, for the meteorological and environmental applications, also for the aviation safety and efficiency improvement solutions. As I mentioned that ESA has launched the first generation of space wind LiDAR in 2018, and our team supports the ground-based validation and calibration for the ESA. Myself also the PI of this activity, also the chief scientist of Dragon Project, cooperated with the Ministry of Science and Technology of China and the European Space Agency. We use this ground-based Doppler wind LiDAR for this air loss validation. Here you can see we measure the wind, aerosol, and the clouds when the air loss passing our ground-based LiDAR network. We have over 20 or 30 ground-based stations in China, and this blue and pink track shows air dust descending and ascending track, and the red dot shows LiDAR measurement here, and we measure the boundary layer measurement. All right, this slide shows two major instruments for the air dust spaceborne LiDAR validation. And left side is wind scanner, and the right side is wind profiler. Both of them working at infrared wavelengths, which is 1.5 micron, with high repetition rate of 10 kilohertz, can measure the wind from the ground, let's say 30 meters to up to 10 kilometers, and with four measurements per second, with the resolution or precision of 0.2 meter per second. And you can see this very compact system. The large scanner only about 80 kilogram, and the wind profiler is about less than 30 kilograms. Very easy to deploy for field campaign. This slide shows this retrieval of wind field. As we all know, that LiDAR can only measure the line of sight information, line of sight, Doppler wind, and aerosol backscattering. With multiple scanning strategies, we can retrieve all the wind direction and the vertical distribution of the turbulence intensities as well. This slide shows wind profiler measurement up to 10 kilometers. As we know, that coherent Doppler LiDAR, the scattering based on the aerosol, or we call it me-scattering. So we need the particle to give the strong enough return signals. So in the boundary layer around 1.2 or 3 kilometers, there are enough signal-to-noise ratio. Or in a high altitude, if there are cloud or optical thin cloud, you can get the return from cloud inside. So you can get the wind speed and the wind directions profiler, as this slide shows. We have deployed this Doppler wind LiDAR at many locations. This slide shows the co-located measurement with radio wave weather radar in the coastal area of China, in Xiamen City. The Leice LiDAR has been passing several international verification tests, including WindGuard and DMGL. We tested this ground-based LiDAR with standard wind mast, with very good correlation both for wind speed and wind direction. For wind speed, let's say the standard deviation is less than 0.13 meter per second. The bias is about 0.03 meter per second. And correlation coefficient is larger than 0.99. So it's very good correlations between the standard reference mast. So this slide shows our nacelle mount LiDAR for the wind turbine measurements. You can see each line of sight measurements is quite good with correlated wind mast measurements. And we also deploy our LiDAR for the offshore wind applications. Thanks to the very compact size and the lower power consumption, it's very easy for offshore wind applications. We have tested the system in the coast of China more than 18 months. So the data availability is over around 100%. And also the LiDAR, we have deployed this LiDAR in all kinds of floating platform, and we passed this test for the OW stage 2. So Leice floating LiDAR has passed the IEA and OW stage 2 criterion test, and with very good correlation compared to the ground-based Doppler wind LiDAR has been certificated by the wind mast. Also compare this with the offshore wind mast. So far, we have deployed over 20 units for the offshore wind LiDARs for this offshore wind sighting and wind power forecasting, including the floating platform and also the fixed platform offshore wind industry. For aviation meteorological applications, we develop our own Doppler wind LiDAR and also its algorithm to recognize and forecast the low-level wind shear. And this work has been sponsored by the Boeing company since 2014 and cooperated with the China Air Traffic Management Bureau of Civil Aviation. We have tested the system in Beijing and Qingdao and many airports in China. This slide shows our partners and users in different application fields, including Meteorological and Environmental Bureau of China, and so the wind industry and the civil aviation, including the airport and the air traffic management industries. Okay, this slide brings me to the end of my presentation. We have deployed over 100 units in China for meteorological applications, and we like to collaborate with the audience and partners all over the world. Thank you. I'd like to take any questions if you have.
Great. Thanks to Leice Lidar for putting that together for us. Really interesting. I think they can't be here at the moment. There's a bit of a time difference, of course, in China. But you can ask them any questions if you like directly. So from here, if you want to leave this session and then make your way to the tab on the platform that says remote sensing all the way on the right. And then from there, you can see a lot of the technology and innovation that's sort of come for this one-day event. So please, log out of here or just leave this session. Just click that tab and go and have a look. We'd really appreciate it, as would the companies involved. And of course, from Leice Lidar's point of view, you can go to their booth as well, and you can ask questions directly, and they'll get back to you there. But thanks everybody for watching. Apologies for the technical hiccup earlier, but we've got another session in about 25 minutes, so plenty of time to have a look around the exhibition area, which is the remote sensing tab. Thanks again. See you soon.